This video is going to cover page 7. It should say page 8 at the very bottom. This is going to be the last page that you have to do because page 9, technically page 8, is the same as page 6, which is technically page 7. So you do not have to do the very last page if you did page 6. So the one before this one. So this is going to cover page 7. It should say page 8 on the very bottom. All right, so number 1 says, draw and shade a tape diagram on the given fraction. And then step 2 says, record the decomposition of the fraction in 3 different ways using number sentences. So here is my tape diagram that I created for this fraction. It is 12 parts, and 10 of those 12 are shaded in. And then, so I created I think 4 number sentences. So you could have done 10 12. There's other answers besides the one that I did. So if you want to check to see if your answer is correct, if I don't have that one listed, then you can just comment on this video. So 10 12s, you could have done 5 12s. So 5 on the top and then 5 12s on the bottom. That would equal 10 12s. That would also be the same thing as 10 12ths is equal to 2 times 5 12ths, since we're doing that twice. So repeated addition is same thing as multiplication. And then I also did 10 12ths plus 2 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 12ths 5 times. So if you do 2 12ths 5 times, then it will equal 10 12ths as well. And then I showed that as a multiplication sentence as 10 12ths times 5, or 10 12ths is equal to 5 times 2 12ths. So that's just this, this repeated addition in a multiplication sentence. All right, so B says 5 fourths. So this one's a little bit different because the denominator tells us what the whole number is. So 4 fourths would equal 1 whole. So 1, 2, 3, 4 parts is equal to that 1 whole. So this is an improper fraction since our numerator is bigger than our denominator. So 4 is our 1 whole, and then that extra one part is equal to 5 fourths. So that's what your tape diagram should look like. I do want you guys to label the 1 whole on this one just because it's different than what is shaded in. So to show this as a number sentence, I did 5 fourths is equal to 2 fourths plus 3 fourths, since 2 plus 3 is 5. So that would work for that one. I also did 5 fourths is equal to 1 fourth plus 1 fourth plus 1 fourth plus 1 fourth plus 1 fourth 5 times, which equals 5 fourths. And then that as a multiplication problem would be 4 fifths times 4 fifths is equal to 5 times 1 fourth, since we have 1 fourth 5 times. So that could have been the 3 problems on B, the 3 number sentences on B. And then for C, it's kind of like B as well. It's an improper fraction. So that 5 tells us that 5 fifths is equivalent to 1 whole. So I have 1, 2, 3, 4, 5 is equivalent to 1 whole. So I do want you to label that to make sure that you know that the whole 6 is not, the 6 parts is not equal to 1 whole. It's just the 5 parts. So for this one, the number sentences you could have done, 6 fifths is equal to 3 fifths plus 3 fifths, so 3 parts plus 3 parts. You could also have done 6 fifths as a multiplication problem. 6 fifths equals 2 times 3 fifths, since we have 3 fifths twice. You could have also had 6 fifths is equal to 2 fifths plus 2 fifths plus 2 fifths, so 2 parts plus 2 parts plus 2 parts. And then that as a multiplication sentence would be 6 fifths is equal to 3, since we have 3 of them, times 2 fifths. So 3 times 2 fifths is equal to 6 fifths. Questions on that one, you can just put in the answer below.